Hello dear students, welcome back to our physics channel, Physics with Jagan sir, and this is your physics sir. And we had successfully completed 10 classes on Newton's laws of motion, and in our last class we have seen friction, and on friction we have seen some conceptual problems also. Now the second part of the friction is some of its applications of the friction. See, first application is angle of friction. Angle of friction. Suppose an object is present here, a force is acting on this object, and obviously normal force will act on the object, and because of the roughness, frictional force will act, right? Now this normal force and frictional force are the vector components. Obviously a resultant will form, according to our vectors chapter, a resultant will form, and this resultant will make an angle phi, let us assume phi, with the normal vector, resultant vector making an angle with the normal vector. That phi is known as angle of friction. Phi is known as angle of friction. First point it is, right? Then the second point, see here, we know F is equals to mu n. F is equals to mu n, and from diagram tan phi is equals to vector, opposite vector is f, and this is parallel to opposite vector, I am keeping it as f. Adjacent vector is n, f by n. So tan phi is equals to, f is equals to mu n means mu into n by n get cancelled, then tan phi is equals to mu. This is what is angle of friction, first concept. Now let us go for the second one. Pull is easier than push. Pull is easier than push. Let us verify is this is the correct statement, that the pulling is easier than the pushing. Now let us consider a block is present here. Over this block a force is acting. This force will have two components. If it is making an angle theta, this will be f cos theta and this will be f sin theta, and mg will act in the downward direction, normal force will act in the upward direction, and frictional force will act in backward direction. And apart of these forces, no other forces are acting on the system, right? Now sigma fx is equals to ma. System is about to move, it is not in motion actually, about to move. Then can I say on x-axis f cos theta is acting, minus friction is acting, and the object is at rest position, so acceleration becomes 0. Then f cos theta is equals to frictional force f cos theta is equals to f. Similarly sigma fy is equals to ma, and obviously the object is neither moving in the upward direction nor moving in the downward direction, so acceleration remains 0, and upward direction forces are acting is n is equals to f sin theta plus mg, and c, let it be equation number 2, and can I write this is equation as f cos theta is equals to mu n. Let it be equation number 1, let it be equation number 2. Now substitute equation 2 in equation 1. We will get f cos theta is equals to mu f sin theta plus mg, right? Then mu f sin theta, mu mg, f cos theta, right? F cos theta minus mu f sin theta is equals to mu mg f cos theta minus mu sin theta is equals to mu mg. Then f is equals to mu mg by cos theta minus mu sin theta. This is the required amount of force for pushing case. Let us go with the next one for pulling. Case. For pulling case, see here, object is present here, and over this object a force is acting, and obviously this will be f cos theta, and this will be f sin theta, this will be mg, and frictional force will act in the backward direction, right? Now sigma fx is equals to ma, and obviously object is about to move but not moving, so acceleration remains 0 on the horizontal axis, and f cos theta minus f is equals to m0, and can I write now f cos theta is equals to f cos theta is equals to mu n. Similarly here along vertical axis, this is along horizontal. Now along vertical n plus, of course, sigma fy is equals to may, and of course the object neither moving in the upward direction or downward direction, so acceleration becomes 0 on the vertical axis. Then n plus f sin theta minus mg m0, n is equals to mg minus f sin theta. Let it be equation number 4, let it be equation number 5. Now substitute 5 in 4, f cos theta is equals to mu mg minus f sin theta, right? That means f cos theta mu mg minus mu f sin theta. So f cos theta plus mu f sin theta is equals to mu mg. Then f cos theta plus mu sin theta is equals to mu mg. Then f is equals to mu mg by cos theta plus mu sin theta. This is for pulling case. Notice one most important point here. For pushing case, we got here negative sign. For pulling case, we got here positive sign. So comparing these two equations, where negative sign exists, this is less quantity than, and this will be high quantity. So for pushing case, it is negative means, this will be less, this will be high. For pulling case, it is positive means it will be high, vice versa it will be less. So force due to pushing is greater than force for pulling an object, right? Again I am saying, there we have negative sign, so comparative to this one, that negative sign component will be less magnitude. So if this denominator is less means obviously force will be maximum. This is what says force for pushing is greater than force for pulling. Clear? Then next one, minimum force required to move a block. F cos theta, F sin theta, F friction, mg normal. And just now we have seen F is equals to mg by cos theta plus mu sin theta, right? Chalo, I am in confusion. Let us see. F cos theta is equals to mu n mu mg minus F sin theta, right? Then F cos theta, then mu mg F cos theta, right only, mu sin theta, then F is equals to, this is what actually I found in the previous concept only, but because I forgot writing mu here, that's why I am again solving the same thing, mu sin theta. And this is what is force required to pull an object, and if the situation is minimum force required to move a block. Minimum force required to move a block. Now, for minimum F, right, cos theta plus mu sin theta should be maximum. Am I right? Should be maximum. And it is maximum means d by d theta of cos theta plus mu sin theta is equals to 0. Then cos theta means minus sin theta plus mu cos theta is equals to 0, and mu is equals to sin theta by cos theta, which is equals to tan theta, right? Then let it be equation number 1. Substitute 2 in 1. Substitute 2 in 1. F is equals to mu mg by cos theta plus mu sin theta. So mu value is tan theta. So tan theta mg by cos theta plus tan theta sin theta, right? Now F sin theta by cos theta mg by cos theta plus sin square theta by cos theta. It says F is equals to sin theta mg by cos theta by sin square theta plus cos square theta by cos theta. These two will get cancelled. F is equals to mg sin theta by sin square theta plus cos square theta is equals to 1. So F minimum force required to pull an object is mg sin theta, right? Now next application is angle of repose and angle of sliding. See here, whenever an object is placed at this point, at this location, when the object is moving in the upward direction and hinged at this point, it is tilting, plane tilting, and at a particular instant, up to particular instant, the object would not slide on the inclined plane, and at a particular situation, this will try to slide in the downward direction, right? At what angle the object is about to slide, that angle is known as angle of repose, right? Now this will be the mg. So originally mg is like this vector is tilting like this, so this will be the angle theta, and it will be mg cos theta, it will be mg sin theta, and this will be the direction of friction, and this will be the normal, right? perpendicular to the inclined plane, to the inclined plane, sigma f is equals to ma, and perpendicular to the inclined plane, this is not moving in any of the either of the directions, so n minus mg cos theta is equals to m into 0, then n is equals to mg cos theta, and along the inclined plane, and the system is about to move, so it would not getting any acceleration, it's just about to move, so sigma f x is equals to, or sigma f is equals to ma, system is about to move, so obviously it is not getting acceleration, means acceleration value becomes 0, right? And downward direction I am considering positive, mg sin theta minus f, mg sin theta minus f, and mg sin theta minus mu n is equals to 0, or mg sin theta is equals to mu n value is equals to mg cos theta. So mg will get cancelled, and mu is equals to tan theta. It says that here the angle of repose value is equals to tan theta. That means coefficient of friction, static friction. That static friction value, if avoids, or if the static friction values exceeds, then only the block will move in the downward direction, try to slide in the downward direction, and that will get extra, or that will get an excess of force, static frictional force, at an angle of tan theta, right? Then next one is, let us see an example over these concepts. An object of mass 10 kg is to be kept at rest on an inclined plane making an angle of 37 degrees to the horizontal by applying a force F along the plane upwards as shown in the figure. See very carefully, inclined plane, force F is acting in the upward direction. The coefficient of static friction between the object and the plane is 0.2. So mu s is equals to 0.2, right? Find the magnitude of the force F. Here we have two situations. Case 1, if object moving upward direction. If the object is moving in the upward direction, so obviously friction will act like this, and mg sin theta like this, mg cos theta, normal, right? Now n is equals to mg cos theta, and because force is acting in this direction, the object is about to move in this direction, so friction will act in the opposite direction. Now F is equals to mg sin theta plus F is equals to mg sin theta plus mu n, F is equals to mg sin theta plus mu mg cos theta. Then F is equals to m value is 10, g value is 10, sin 37, mu value is 0.2, 10 cos 37. Then F is equals to 100, 3 by 5, 20, 4 by 5, 60 plus 80, 140 Newton. This is 140 Newton. This is one case. if object is moving in downward direction but object is moving in the downward direction means frictional force will act in this direction, and this will be mg sin theta, mg cos theta, normal, then n is equals to mg cos theta, and f plus f is equals to mg sin theta, because object is not moving, so acceleration becomes 0, right? Then f plus mu n mg sin theta, f plus mu mg cos theta, mg sin theta, then f is equals to mg sin theta minus mu mg cos theta, right? F is equals to mg sin theta value we got here 60, right? Mg sin theta 60, mg cos theta 80, 60 minus 80, f is equals to minus 20. So obviously it is not correct case, because f value is they are representing in the upward direction, which we are considering generally as positive direction, but here it is giving negative value in the second case. So obviously the value we required is 140 newtons. Clear? Now let us go with the next one. See second problem. A 5 kg block slides down an inclined plane 30 degrees with a horizontal. That is, it is making an angle 30 degrees and block is sliding. Find the acceleration of the block if the plane is frictionless. If the plane is frictionless means mg sin theta, and acceleration is attained only due to the mg sin theta, right? So sigma f on inclined plane, sigma f is equals to ma, right? mg sin theta is equals to ma, a is equals to g sin theta, a is equals to g value is 10, sin 30, that is 10, 1 by 2 is equals to 5 meter per second square. This is the first one. The acceleration if the coefficient of kinetic friction is 1 by 2 root 2. mg sin theta, friction is acting in the leftward direction because of the presence of mg sin theta, the block is about to move in the downward direction, so frictional force will definitely act in the opposite direction to the relative motion, right? Now this will get an acceleration, this will be the n, this will be the mg cos theta, right? Now n is equals to mg cos theta and mg sin theta, it is moving in the downward direction. I am considering ma because friction is acting in the opposite direction. mg sin theta, mg sin theta, mg cos theta is equals to ma, then m get cancelled, then a is equals to g sin theta minus mu cos theta, mu g cos theta. So a is equals to 10 sin 30, mu value given as 1 by 2 root 3, 10 g value cos 30, a is equals to 10 by 2, 1 by 2 root 3, 10 root 3 by 2, 10 by 2, get cancelled, 10 by 4, 10 by 4. So this becomes 20 by 4. Let us assume 10 by 4 is the answer, that is 5 by 2, 2.5 meter per second square. This is the required acceleration. Clear? This is the second case, and from today onwards I am going to give you a question as the homework, and if you really need its answer, let me know through the comment box. I will try to give you the answer or solution, whatever you are requesting. And here I am discussing these questions to make you to be more comfortable with the subject. And the next point is, as I am telling daily, better to practice my class notes first of all, and after that better to practice your worksheets. And if you still do not have the worksheets, don't worry, you can message me, you can comment me on the comment box, you can let me know in YouTube comment box. So definitely I will try to send the amount of stuff which is beyond your estimation, because I have that much amount of stuff. And the next point is, as usually, for daily practice papers and weekend examination papers, you better to follow my Telegram channel, Physics with Jagan sir, and whatever the stuff you are requesting, I will definitely post in the Telegram channel, Physics with Jagan sir. Have a great day, take care, bye bye, and don't forget to solve this question. Bye bye.